Good morning, everyone. Welcome back. In today's lesson, we're going to discuss about confusion matrix. Also known as error matrix. A confusion matrix is defined as a visual representation of how well the ANPR system performs in detecting and recognizing vehicle number plates. Okay, I say vehicle number plates because we are in the context of ANPR, but if you are in the other context, you will generalize to the context too. So, how do we find the confusion matrix? To find the confusion matrix, we base on what we see as supervisors, because this is a supervised learning. So, what we see as supervisors is called truth or ground truth. That's what we see. What supervisor sees, what a supervisor sees, that's ground truth. And this is what a model sees. What a model sees. That's in the prediction. Okay. Let's begin ground truth. So what's the ground truth here? Let's first draw a table. This is what I see as a supervisor. I see the number. This is positive. The number exists. This is positive. I don't see the number. This is negative. The number doesn't exist. The model sees the number. That's positive. The model doesn't see the number. That's negative. Well, let's now find the matrix. I have the number. I see the number. The model sees it too. See the number? That's positive. The model sees the number too. Number. That's positive. I don't see the number, but the model sees it. That's negative on my side. And that's weird. But that and positive the model side. Weird. Okay. I see the number, but the model doesn't see it. That's positive on my side, but negative on the model side. I don't see the number. The model doesn't see it too. Great. That's negative on one side. Negative on the model side. What's important here is no longer what I see. What's important here is what the model sees. So I will encircle what the model sees. Then let's make a little calculation. Let's take positive as +1. And the negative as -1. Then do a multiplication. +1 times +1, that's +1. +1 times -1, that's -1. -1 times +1, that's -1. -1 times -1, that's +1. +1 +1 is true. -1 is false. -1 is false. True. So this is a true positive. As I told you, what's important here is what the model sees. Because this is AI, it's not natural. It's no longer natural. We're not interested in natural intelligence. We are interested in artificial intelligence. So what the model sees is very important here. That's why we consider this true and positive on the side of the model. That's true positive. True positive. The first cell, this cell is true positive, also abbreviated as TP. This is a false negative. False negative, abbreviated as FN. This is This is false positive and this is true negative. Positive also abbreviated as FP. False true negative also abbreviated as TN. Okay, so this is the matrix. Matrix is TP, FN, FP, TN. Okay, so let's analyze the performance in this confusion matrix. This true positive, that what we desire to have, that's what every one of us desires to have. Because we have a number and we want to model to see the number as we see it. We also have the desire to have the model that's capable of not finding the number where we don't find it to. Actually, that's what we desire. It finds the number where we find it. It doesn't find the number where we don't find it. So, true positive and true negative, that's what we desire. What don't we desire? At least false negative. Because once we see the number and the model can't see it, that's bad. It means either the data is not clear or the model is not well trained. So this is undesirable. Okay, so formulas now. Let's calculate the precision. Precision. Precision P. Precision P is calculated by taking TP or true positives the number of true positives, and dividing by the number of true positives plus false positives. False positives. True positives, false positives. As for recall, the formula becomes true positives over true positives plus false negatives. Well, this is a concern of recalling or remembering. I have the number, but the model is failing to see it. So the model needs more training, but it can't connect what it was trained on and what it's seeing during the self-evaluation. Before you close today's lesson, let me show you the confusion matrix that was provided as output at the end of the training we made previously. Now the confusion matrix. This is predicted. This is true. True means ground truth. For example, do you remember this number? Whatever you don't see around here inside the matrix has a problem. Yeah. Okay. And keep this in memory. I don't say you have to memorize it, but this is a nice matrix to remember. If you can't remember everything, just remember how we deduced it. See you in the next videos. Bye bye.